Areas under the standard normal curve. Our standard normal curve starts close but not crossing. Our horizontal axis is labeled Z. Our curve starts but not touching our horizontal axis. At -3, it starts increasing until we get to 0, which is our mean. Then it starts decreasing until it is again very close to our Z axis at 3. Our standard normal curve has a mean of 0 and a standard deviation of 1. So the numbers along the z-axis are -3, -2, -1, 0, 1, 2, 3. Since most of our data is between -3 and 3, we do not list any other numbers on the horizontal axis. Anytime we refer to the standard normal curve, we refer to this description and this picture. Basic properties of the standard normal curve. Property 1. The total area under the standard normal curve is 1. Property 2. The standard normal curve extends indefinitely in both directions, approaching but never touching the horizontal axis as it does so. Property 3. The standard normal curve is symmetric about 0. That is, the part of the curve to the left of the mean is the mirror image of the part of the curve to the right of it. Property 4. Almost all the area under the standard normal curve lies between -3 and 3. Finding areas under the standard normal curve. Using the standard normal table to find the area under the standard normal curve that lies to the left of a specified z-score. When we draw a picture of our standard normal curve, you draw a curve that increases from left to right until it gets to the mean, then decreases from left to right. You have a point on your horizontal axis Z, and you draw a line from your z-axis to your curve. Then you shade the area under the curve to the left of Z. Example: determine the area under the standard normal curve that lies to the left of Z equals 1.67. First, we want to make a sketch of what this looks like. We are given Z is 1.67, and we want to find the area that is to the left. So we want to go to our normal distribution table. On the normal distribution table, along the side we have our z-scores. So we have 1.6. So this is the row that we are looking at. At the top we have the second decimal place for z. So since it was 1.67, we are looking for the column 0.07. Our table always gives us the area to the left of z. Where the column and the row intersect is at 0.9525. That means A equals 0.9525. Example: determine the area under the standard normal curve that lies to the left of z equals -0.41. Drawing a sketch, our area is to the left of 0. Our z-score is to the left of 0, and the area is to the left of a z-score of -0.41. So again, we want to go to our table. Since our z-score was -0.41, we want the row for -0.4, and then the column for 0.01. They cross at 0.3409. Our area equals 0.3409. Finding areas under the standard normal curve. Using the standard normal table to find the area under the standard normal curve that lies to the right of a specified z-score. This time, when we have our standard normal curve and our point Z on the horizontal axis, when we draw our line from the axis to the curve, we shade the part of the curve to the right of Z. To find that shaded area, it's 1 minus the area to the left of z that we find in our table. Example: determine the area under the standard normal curve that lies to the right of z equals 0.58. First, we want to draw a picture. Our z-score is to the right of 0 since it is positive. Because we want to find the area that lies to the right, the area to the right of that line is shaded. When we go to our table, we'll find the area to the left of that line. Since z equals 0.58, I find my row of 0.5, then my column of 0.08, and they cross at 0.7190. This gives us A equals 1 minus 0.7190, which equals 0.2810, which is the area to the right. Another option that we have in our table, since our curve is symmetric, I could have looked up the area for negative 0.58, which was 0.2810. And then we could have gone directly to our answer, which was 0.2810. Example: determine the area under the standard normal curve that lies to the right of z equals negative 1.55. Drawing our sketch, our area is shaded to the right of negative 1.55. I have two choices. I can find the area to the left of negative 1.55 and then subtract it from 1, or I can just find the area of z equals positive 1.55. For this problem, I'm going to find the area for negative 1.55. So I have negative 1.5 and then 0.05, and they cross at 0.0606. Again, this is the area to the left of my z-score. So my next step is A equals 1 minus 0.0606, which equals 0.9394. Finding areas under the standard normal curve. Using the standard normal table to find the area under the standard normal curve that lies between two specified z-scores. We have our standard normal curve, but this time we have two spots on our horizontal axis, z1 and z2. There is a line from the axis to the curve at z1 and another line from the axis to the curve at z2. The area between those two lines is shaded. Using the values from the table to find the shaded area, it's the area to the left of z2 minus the area to the left of z1. Example: determine the area under the standard normal curve that lies between z equals negative 1.25 and z equals 1.25. We have our picture of the standard normal curve. This time we have two lines and the shading is between those lines. For z equals negative 1.25, we want to find our area using the table. Under z, we want to find negative 1.2. Then we go to the column for 0.05. And where they cross is the area for negative 1.25. That area is 0.1056. The next z-score is 1.25. So we want to find that area on our table. So we want to find the row for 1.2. And then our column for 0.05. And they cross at 0.8944. Find the area that is shaded between negative 1.25 and 1.25. So we have A equals 0.8944 minus 0.1056, which gives us a total area of 0.7888. Example: determine the area under the standard normal curve that lies to the left of z equals negative 1.55 and to the right of z equals 1.48. So we have a picture of our standard normal curve. We have lines drawn to the left of my mean 0 and to the right of my mean 0. But this time, instead of shading between those lines, I shade to the left of my line to the left of 0 and to the right of my line to the right of 0. So I want to find that total area. My first step is to take z equals negative 1.55 and find the area that lies to the left of that z-score. Going to my table, so I find the row of negative 1.5 and then the column of 0.05, and they cross at 0.0606. So A equals 0.0606. For the z-score of 1.48, I want the area that lies to its right. Unfortunately, the table gives us the area that is to the left. So once I find that, I need to subtract it from 1. So going to my table, I go to the row for 1.4, and then for the column of 0.08, and they cross at 0.9306. So to find the area, A equals 1 minus 0.9306, which is 0.0694. I could have also used the table with a z-score of negative 1.48, which would have given me the area of 0.0694. Now to find my total area, since I want the area to the left of z equals negative 1.55 and to the right of z equals 1.48, I need to add my two areas together. A equals 0.0606 plus 0.0694, so my final answer is 0.1300. Determine the area under the standard normal curve that lies to the left of z equals 0.24. First, I want to draw my standard normal curve. A z-score of 0.24 is going to be to the right of 0. So I draw my line from my horizontal axis to my curve and shade to the left of that line. This time, instead of using our table, we're going to use the calculator. Choose the Distribution menu, second, VARS, and I want the second one, Normal CDF. Enter. First, I need to type in my lower bound. Since it is shaded to the left, I need a really small number to be my lower bound, like negative 1,000. Just as long as it's a sufficiently small number, it'll work. Comma. Then I type in my z-score of 0.24. Since I'm using a mean of 0 and a standard deviation of 1, and those are the defaults, I can close my parentheses, enter, and I get an area of 0.5948, because we want 4 decimal places. If you have a stat wizard, when you go to second, VARS to get your distribution menu, and you go down to 2 and press enter, it will ask you for your lower bound, your upper bound, the mean, the standard deviation, and then paste. I'm leaving the lower bound of negative 1 times 10 to the 99th power. I'm going to go down to my upper bound, which is my z-score, 0.24. I want 0 for my mean, 1 for my standard deviation, and then enter. And it is typed just like it was with the other calculator. Enter again, and I get the same area of 0.5948. A equals 0.5948. Example: determine the area under the standard normal curve that lies to the right of z equals 1.35. So I draw my standard curve. I'm going to draw the line to the right of 0 since my z-score is to the right of 0. Again, the line goes from the horizontal axis to the curve, and I shade to the right of that line. Going to my calculator, choose the Distribution menu. Number 2, Normal CDF, enter. This time my lower bound is my z-score, 1.35, comma, and then for my upper bound I want to type a very large number. I'm going to use 1,000. Since I'm using a mean of 0 and a standard deviation of 1, which are the defaults, I'm going to close the parenthesis and press enter, and I get 0.0885. If my calculator has the stat wizard, I still use second, distribution, and number 2, normal CDF, enter. This time, lower limit is my z-score, 1.35. My upper limit, I can use a really big number. So 1, second, comma, is my scientific notation, and I'm going to type 99 as the exponent. I want my mean to be 0, my standard deviation to be 1, then enter, enter again, and I also get 0.0885. So A equals 0.0885. Example: determine the area under the standard normal curve that lies between z equals negative 0.82 and z equals 2.01. I draw my standard normal curve with a line to the left of 0 and a line to the right of 0. Then I shade between those two lines. This one is the easiest to find on our calculator because my smaller z-score is my lower bound and my larger z-score is the upper bound. Going to my calculator, second, distribution, normal CDF, then I type my smaller z-score, negative 0.82, comma, 2.01, close parenthesis, enter, and I get an area of 0.77167, which rounds to 0.7717. If I have the stat wizard, second, distribution, I want number 2, normal CDF, my lower bound is negative 0.82, my upper bound is 2.01, my mean is 0, my standard deviation is 1, enter, enter again, and I also get 0.7717, which rounds to 0.7717. So my area equals 0.7717. Given the area, find the z-score. 1. Determine the cumulative area. 2. Locate the area in the standard normal table. 3. Find the z-score that corresponds to the area. Pictorially, we have our standard normal curve. We have 0 for our mean and a z-score on our horizontal axis. We have a line drawn from our horizontal axis to the curve, and the curve is shaded to the left, and that's our area. So we'll be given the area, and then we have to come up with the z-score that goes with that area. Example: find the z-score such that the area under the standard normal curve to the left is 0.91. So I draw a standard normal curve with the shading to the left of my line. I have a couple of options to find this value. One is using my table. When I use my table, I have to look for the area. So I'm looking for 0.91. The best I can get, 0.9009 or 0.9115. Since 0.91 is closer to 0.9099, I use the z-score for the row and the column to estimate z. So my row is 1.3 and my column is 0.04. Z equals 1.34. Another option is to use our calculator. It's rather difficult to go through all of those areas and then try to guess which area it's closest to. Our calculator will give us an accurate answer. We want our distribution menu again, second, DISTR. This time we want number 3, which is inverse norm. Enter. Inverse norm is set up to take an area that is shaded to the left. So I type in my area of 0.91. By default, the mean is 0 and the standard deviation is 1. I press enter and I get my z-score of 1.34. If I have a stat wizard, second, distribution, number 3, inverse norm, enter, my area, 0.91. I want my mean to be 0, my standard deviation to be 1, enter, enter again, and I get 1.34 again. Example. Find the z-score such that the area under the standard normal curve to the right is 0.94. So first I want to draw a standard normal curve. I draw a line from my horizontal axis to the curve and then I shade to the right of that line. I'm going to just use my calculator for this one. The calculator is designed so that when I type in the area, it assumes it's to the left of the z-score. Second, distribution. I go down to inverse norm, enter. Since it is shaded to the right, I'm going to type in 1 minus 0.94. That way, it will find the area to the left and give me the corresponding z-score. Enter. And I get negative 1.55. Z equals negative 1.55. The Z sub alpha notation. The symbol Z sub alpha is used to denote the z-score that has an area of alpha to its right under the standard normal curve. Read our Z alpha as Z sub alpha, or more simply, Z alpha. When I see the notation of Z sub alpha, I have my standard normal curve, I have Z sub alpha on my horizontal axis, a line drawn from that axis to the curve, and the area alpha is the area shaded to the right of my z-score. So when I see the notation, they are giving me the area to the right of z. Example. Find the value of z sub alpha, z sub 0.17. Again, they're giving us the area that is to the right of my z-score. So I'm going to go to my calculator, second, distribution. I want number 3, inverse norm, and again I'm going to type in 1 minus, and in this case I'm going to use my alpha of 0.17. I want to leave my mean at 0, my standard deviation at 1, enter, enter again, and I get a z-score of 0.95. Z sub 0.17 equals 0.95. Example, determine the two z-scores that divide the area under the standard normal curve into a middle 0.39 area and two outside 0.305 areas. First, I want to draw my standard normal curve. I'm going to have two z-scores, so I draw two lines. The problem says that the middle has an area of 0.39. Then it says that the two outside areas are 0.305. So I have 0.305 to the right of my line and to the left of my line. Since both the table and the calculator are set up to take areas to the left of my z-score, I'm going to use the area to the left of my line, 0.305, to help me find my z-score. Since it is symmetric, when I find my two z-scores, one will be positive, one will be negative, but they will be the same number. Heading to my calculator, second DISTR, we want number 3 inverse norm. We're going to type in our area to the left, 0.305. We want our mean to be 0, our standard deviation to be 1. Enter, enter, and I get negative 0.51. The z-scores are negative 0.51 and positive 0.51. To recap, areas under the standard normal curve. The basic properties of the standard normal curve. The total area under the standard normal curve is 1. The standard normal curve extends indefinitely in both directions, approaching but never touching the horizontal axis. The standard normal curve is symmetric about 0. Almost all the area under the standard normal curve lies between -3 and 3. Finding areas under the standard normal curve. If we have a left-tailed curve, then we can use our z-scores to locate the area. If it's a right-tailed curve, once we find the area on our standard normal table, we have to subtract that area from 1. If it is between, then we find the area for both of our z-scores, take the larger area and subtract it from the smaller area to find the area between the two z-scores. The z sub alpha notation. The alpha is the area to the right of my z-score. So whatever the value is for alpha, I need to make sure I subtract that from 1 to get the area to the left before I find the corresponding z-score.